Okay, so let's look at the two problems that I assigned for homework from 2.3. That was 128. And so we had the function y equals 1 plus x squared to the power 3. And then this was just the graph underneath this function that then was rotated around the y-axis. So because it's the y-axis, the book treats more general cases, but I'm treating only the y-axis, and we know that for us this means, as I said, there are more general cases, but we don't do this. For us this means the shell method. Okay, and so the shell method is the formula for that, so let's write down the v shell is a 2 pi, the interval over which you work, and then it's the top, it's x times the top curve minus the bottom curve, dx. Okay, x represented the radius of the shell, and this f top minus f bottom, the height of the shell. Okay. And so in this case, there is only a top curve here. This is the curve that's given. So they give us also intervals. So on the interval, I hope you can read this x equals 0, x equals 1. That means the interval from 0 to 1. I will always say it in terms of intervals, not the way the book has formulated it. Okay, so what do we need to do? Well, it's 2 pi from 0 to 1 x times the function 1 plus x squared cubed dx. Now, some of you might have thought, okay, I'm going to expand the whole thing because I have to write everything in powers of x and then integrate. True, that's correct, but there's a much quicker way here. So sometimes you have to pay attention whether substitution is possible always. Always substitution is something you makes things really sometimes easy. And so here we see that it's 1 plus x squared. If I do the substitution, u is 1 plus x squared. Then the derivative of that is 2x dx, which is almost what we have. That's an x dx. So du over 2 is x dx. Now it's a definite integral, and it also pays off once you have a substitution with a definite integral. So remember this for the definite integrals, is that if you so the original endpoints were 0 and 1, you change the endpoints now into the u values of it. That means you plug in here what if x is 0, then u is 1, and from that equation we see that if x is 1, then u is 2. Okay, so this means now we can replace everything. We have, let me write it here, otherwise I get, so this is equal to 2 pi, the integration now from 1 to 2, right? I use the u endpoints now. Then we have x dx. So remember, so just in case that this x dx is these two guys that I put together, right? That is du over 2. And then what else do I have? I have a u cube. Okay? So the these twos cancel. I get pi, the antiderivative of u to the third is u to the fourth over 4, and this between 1 and 2. So it is pi over 4, and then we put in 2, which is 16 minus 1. So this is 15 pi fourths. Okay? There's nothing more to it than that. And then the other question, there we have, I think, if I remember well, that was 145. We have now two curves, I think. Let me see. I forget now what the question was. Yeah, so we have y is radical x, and the other one is y is x squared. Okay, so we have still the region bounded by these two that we now rotate again around the x-axis. Around the y-axis, of course, that's what I meant. So what we now need to do is we find the intersection points. Step 1. We need the intersection points. So we put radical x equal to x squared. We get rid of the radical by squaring, so that gives me x equals x to the fourth. And so now be careful now, don't scratch out, but always factor x to the fourth minus x, that is x times x cubed minus 1. Now x cubed minus 1, you look for possible roots and you see x equals 1 is a root. Okay, so we need to do long division. So we have x, and then we're gonna do x cubed minus 1 divided by x minus 1. Okay, I'm not gonna write it down because I always get confused where it goes to what. And if you work this out, I'm not gonna work it out here. It is x squared plus x plus 1. That's the result. Now, can you factor the next one? And you see no, because if you do this is a quadratic irreducible. This is a quadratic irreducible because its discriminant, remember the discriminant was b squared minus 4a, right? And in this case it would be 1 minus 4 is negative 3, that is a negative number. And that's exactly what the quadratic irreducible look like. This means therefore it cannot be factored further. So we have only two intersection points, x equals 0 and x equals 1. Okay. So step 2, now we put them into a nice little table. So we have 0 and 1, and we have radical x and x squared. So we need a test point. I'm going to use 1/4. Why do I take 1/4? Because if I take the square root of 1/4, that's a half. And if I take the square of that, it's 1/16. And now it's clear that this guy is the bigger. So with our formula, we know that this will be the bigger one, which is the square root of x, and this will be x squared. Okay, so we have 2 pi between 0 and 1, x times radical x minus x squared, right? That's how I said it, right? Okay, dx. Now this one we have to expand. And so this is 2 pi, 0, 1. This radical we write as a rational power, x to the power half, times x, so it's x to the power 3 halves, minus x cubed. If you expand, right, this thing is has exponent 1 plus a half, so 3 halves. Okay, and now it's just a matter of add 1 to the exponent, so that is 5 halves, and divide by that exponent, minus x to the 4th over 4, and this is between 0 and 1. So if I plug in 1, I get 2 pi. Any power of 1 is 1, so it's 1 over 5, that is 2/5, right? The reciprocal of 5 halves, minus 1/4. Minus 0, of course the rest is 0, and so that's the correct answer. I mean, probably in the back of the book they will have put it on common denominator, so that would be common denominator 20, right? So then we would have 8 minus 5/20s, so that is 6 pi over 20 or 3 pi over 10. Okay, that's it.